Hi everyone, I am Teacher Diane. In today's lesson, we are going to talk about whole numbers. We will be discussing the answer to the following questions. Let us look at this example. Which of the following numbers is divisible by 5 and 9? First, can we eliminate anything? Are the numbers all divisible by 5? Yes. A number is divisible by 5 if the last digit is either 0 or 5. So we cannot eliminate. Next, let's see if which of the numbers is divisible by 9. Again, how do we do that? We simply add the digits. Let's look at letter A. 3 plus 4, 7 plus 3, 10 plus 2, 12 plus 5, 17. It is not divisible by 9. 17 is not divisible by 9. Next, how about letter B? 4 plus 6, 10 plus 10 is 20. Again, not divisible by 9. Next, 3 plus 7, 10 plus 8, 18 plus 4 plus 5. That's 18 plus 9, and that is 27. 27 is divisible by 9. So there you go. That's our answer. Letter C. Given the number 83,201p, in order for this number to be divisible by 3, 6, and 9, p must be. Recall divisibility rules by 3, 6, and 9. They are related, correct? But first, let me look at this, divisible by 6. Recall that if you are divisible by 6, you are divisible by 2 and 3. So that means P cannot be equal to 5, right? Because if the last digit here is 5, it cannot be divisible by 2. So that's eliminated. So we're left with A, C, and D. Let us try A. Let us first add what we have over here, the digits. 2 plus 1 plus P. We have 11 plus 2, 13 plus 1, that's 14. 14 plus something, it should be divisible by 3 and 9. Can P be equal to 4? If P is equal to 4, then this will be 18, right? And 18 is divisible by 3 and 9. Automatically, it's also divisible by 6. Its last digit is 4. It's divisible by 2. So if you're divisible by 2 and 3, you are also divisible by 6. So therefore, our answer is letter A. Next, Mrs. Owen has 27 desks in her classroom. She wants to put the same number of desks in each row with no desks left over. How many rows could Mrs. Owen make? What kind of question is this? This is just a matter of finding out which of these numbers can divide 27, right? And what is the answer there? The answer is letter B, because 9 can divide 27. Okay, because it says here that there is no desk left over. So meaning to say there should be no remainder. Pause this video and try to answer it by yourself. Assuming that you have already paused the video, let's answer this. This number here is divisible by, is it divisible by 4? What's the divisibility rule for 4 again? You just look at the last two digits. Is 54 divisible by 4? Let us see. No, right? You have a remainder of 2. So, eliminate. Definitely, this one cannot be divisible by 5 because its last digit is 4. Usually, when I'm solving and then I already eliminated the first two choices, I always go to the last choice. That's just my technique. Okay? So let's see, is this divisible by 9? And actually, I would prefer to check that instead of checking if it's divisible by 8. Because if you want to see if it's divisible by 8, you would have to check the last three digits, and I do not want to divide. Okay? So let's look at choice D. We add the digits, right? Check if the sum of the digits is divisible by 9. So we have 5 plus 8, 13, plus 2, 15, plus 3, 18, plus 5, 23, plus 4, 27. There you go. 27 is divisible by 9. So the answer is letter D. For this one, again, pause the video and then come back to it after you have solved the problem. Assuming that you have already answered this, let us now discuss. So it says here that Arlene has 210 mangoes containing the same number of mangoes. Then each of the following could be the number of mangoes per basket except, okay, which among these? You can end up with 21 mangoes, right? Because 210 is divisible by 21. So that means you have 10 baskets. You cannot have 20 mangoes. The answer is letter C. 210 is not divisible by 20 because you would end up with a remainder of 10. A group of more than 10 and fewer than 20 students who pay the same amount for a class field trip. If the total amount collected was 16,490, how many students were in the group? So for this one, we have no other option but to check which of these numbers can divide 16,490. The answer is letter C, 17. 16,490. When you divide it by 17, so look at this. If you look at 164, it's already very close to 17 times 10 or 170. So I would be expecting that this is 9. Each of them paid 970 pesos. If a number n is odd, which of the following must also be odd? So what will we do here? Plug in specific numbers. It says here that n is odd, so get an odd number. Let's say 1. I always use 1 because 1 is the smallest odd number. Which of the following must be odd? So if n is equal to 1, what is n plus 1? This will be 2, and this is even. Letter B, n over 2 will be equal to 1/2. And it's not even, it is not a whole number, correct? So no. How about n plus 2? So this one will be 1 plus 2. 3. And this is odd. We found the answer. Letter C. If x is a whole number greater than 1 and the product of x and x plus 4 is odd, then x must be. In this case, what we will do is use elimination. We will try if letter A is the answer. Can x be even? Let's say x is 2. If x is 2, what is x plus 4? So when you substitute, that would be 2 plus 4. So the answer is 6. But it says that the product, let's look at the product. The product of 2 and 6 is 12. But it says here that the product must be odd. So letter A cannot be the answer. Let's try B, odd. Can x be an odd number? Let's say try 1. So if that's the case, x plus 4 is 5. What is now the product? 1 times 5. And the answer is odd. The answer is letter B. What is the greatest common divisor of 54, 36, and 24? What is greatest common divisor? That is the same as GCF. But instead of solving for the GCF, you can just look at the choices. Alright, so since we're looking for the greatest, let us try 9. It's just a matter of checking if 9 divides all of this. But no, right? Because 9 cannot divide 24. How about 6? Because then that's the next highest. Can 6 divide 54? Yes. Can 6 divide 36? Yes. And 6 can divide 24 as well. So the answer is letter C. No computations needed, right? Next, Lexi is making fruit baskets. She has 20 apples and 8 oranges. Lexi wants to make all the fruit baskets identical without having any pieces of fruits left over. What is the greatest number of fruit baskets Lexi can make? What kind of question is this? It's just a matter of looking for the GCF of 20 and 8. What would that be? The answer is letter C, 4, because 4 is the greatest number that can divide both 20 and 8. For instance, you did not know that it's a JCF question. What you can do is you can just substitute the numbers here, use elimination. So if the answer is 8, can there be 8 baskets? No. Because if you have 8 baskets, you cannot put the 20 apples there na meron kang identical number of fruits, right? It cannot be 6 also because you cannot put 20 apples in 6 baskets with having the identical number of apples. Okay? So the answer is letter C. 3 clocks ring once at the same time at 1 p.m. After that, the first clock rings after every 90 minutes, the second after 30 minutes, and the third after every 60 minutes. At what time will they again ring together? It's very important that you imagine what's going on. So let's look at the first clock, clock 1. It rings after 90 minutes and then after another 90 minutes, so that means 180 minutes has elapsed, right? And so on. 360 and so on. For clock 2, every 30 minutes. So at the end of 30, 60, 90, 120, and so on. Clock 3, every 60 minutes. So 60, 120, 180, 240, and so on, right? At what time will they again ring together? Can you imagine now what kind of problem is this? We are looking for the LCM of 30, 60, and 90. And what would that be? Whenever you're looking for the LCM of numbers 30, 60, and 90, what I do is I look at the biggest number, check for the multiples of that, and see whether it is divisible by the other numbers. So for example, 90. Is 90 divisible by 30? Yes, but 90 is not divisible by 60. What about 180? Is 180 divisible by 60? Yes, it is also divisible by 30. 180 minutes. What is 180 minutes? 180 minutes is 3 hours because this is 60 times 3. If they all started at 1 p.m., 1 p.m. after 3 hours, so that's already 4 p.m. The answer is letter D. If a number is divisible by 12 and 16, then the number must also be divisible by what number? Let's start with a smaller number. If a number is divisible by both 3 and 5, then that means it is divisible also by 15. If it's divisible by 2 and 3, it's also divisible by 6. If it's, let's say, 4 and 10, is it divisible also by 40? Is it automatic? No. The answer is that it is divisible by 20. What is the pattern that is going on here? It is saying, class, that what are the relationships of these numbers? These are the LCM. 15 is the LCM of 3 and 5. 6 is the LCM of 2 and 3. And 20 is the LCM of 4 and 10. Going back to this, we're just looking for the LCM of 12 and 16. How do you get the LCM? So there are a lot of ways to get the LCM. One of the ways is by looking at the prime factors, right? So for the prime factors, 16. Let's write the prime factor 3. This is 4 times 4, but they are not yet prime. So 2, 2, 2. This is 4 times 3, and this is 2, 2. So that means 16 is 2 times 2 times 2 times 2, right? And then 12 is 2 times 2 times 3 here. What is the LCM? You bring down everything, but make sure that you have the same number aligned. So that's 3 times 2 times 2 times 2 times 2. This is 16 times 3, so the answer is 48. So that's one method, right, for looking for the LCM. Since we're already here, the LCM is 16, but what is the GCF? You just look at the common. So in this case, the common would be this 2 and 2 here. So the GCF is 2 times 2. It's 4. But of course, it's easy to say that the GCF is 4. Anyway, another way to find the LCM is by doing continuous division. Think of a number which divides both 12 and 16. It doesn't have to be prime. The bigger, the better. 4. And then divide. 12 divided by 4 is 3. 16 divided by 4 is 4. For this one, is there a number that can divide both 3 and 4? No more, right? So if that is the case, this is already our last row. What is now the LCM? The LCM is the number here in the last row. So that's 4 times 3 times 4. This is 12 times 4. You get 48. How many prime numbers are there between 70 and 80? So it's really just a matter of listing prime numbers. So we have 71. It cannot be 72. 72 is divisible by 3, right? 73. We are just looking at the odd numbers. They're candidates for prime numbers. 75. No, this is divisible by 5. 77, this is divisible by 11. 79, yeah. So the answer is letter A.